Assalamu alaikum. Combined capacitance or equivalent capacitance or total capacitance of capacitors connected together. First, we talk about capacitors in parallel. If we have capacitors connected in parallel, like the circuit in front of you, when we connect that capacitors in parallel with battery or potential difference, so they have the same voltage. So in parallel, they have the same voltage, but different current. So here we talk about charge, so different charges. Different charges, it means the Q total equals the Q1. Q total, it comes from the battery. So at this position, this is Q total. And then we have here Q1, Q2, Q3, and so on. So Q total equals Q1 plus Q2 plus Q3 and so on. We know that before the relation between Q and C, that Q equals C times V. So Q total equals here. So Q total equals C total multiply V. We don't say V total because it is the same voltage. So equals C1 V plus C2 V plus C3 V and so on. We cancel V with V with V to get C total. So C total equals C1 plus C2 plus C3 and so on. So if we need to increase the capacitance of capacitors, we connect them in parallel because C total is greater than the capacitance of any one. If we have capacitors C1, C2 and so on connected with a battery in series, they have different voltage, but they have the same charge because the same current, it means the same charge. So the same charge, so it's the same charge. So remember, capacitors in series, they have the same charge, but different voltage. So V total equals V1 plus V2 plus V3 and so on. What is the relation? Remember, Q equals C times V. So V total equals Q total over C total. It is the same charge, so we don't write Q total, just we write Q. V1, it's Q over C1. V2, it's Q over C2. V3, it's Q over C3. We can cancel Q with Q and replace them by 1. We will get 1 over C total equals 1 over C1 plus 1 over C2 plus 1 over C3 and so on. We can rewrite this as C total equals 1 over C1 plus 1 over C2 plus 1 over C3 all to the power -1. The total capacitance in series is less than the capacitance of anyone. So if we need to decrease the capacitance of capacitors, we connect them in series. Let us compare between resistors and capacitors. In series, capacitors in series, they have the same charge. Resistors in series, they have the same current. 1 over C total in case of capacitor, 1 over C1 plus 1 over C2, but R total in case of resistors, R1 plus R2. In parallel, they have, in case of capacitor, they have the same voltage. Also, resistor, they have the same voltage. Parallel, it is C1 plus C2 plus C3, 1 over R total, 1 over R. Look, you can connect this one. So, R total in case of resistors, it is the same as C total in case of series capacitors. And the C total in case of capacitors, the same as R total in case of resistors in series. Let us solve the next question. The figure below shows 3 capacitors So we have 3 capacitors connected in electric circuit. The charge Q in capacitor C1, so here we have Q1, which is 7.5 microcoulomb. C1 already equals 15 microfarad. This is a given from the figure. He said find the potential difference across the battery. C1 connected in parallel with the battery. So the voltage in the battery equals the voltage through C1. So we find V1. Now remember the formula that join Q, C and V. So this is the formula. So the first part here in part A, we find V1, the voltage through capacitor C1. V1 equals Q1 over C1. Q1 it is 7.5 microcoulomb and C1 it is 15 microfarad. We cancel micro with micro, so 7.5 divided by 15 it is 0.5. Okay, coulomb over farad it is volt, so 0.5 volt. V1 equals the voltage through the battery. So the voltage through the battery is 0.5 volt. Part B, he said calculate the quantity of a charge passed through X. The charge passed through X, it is the charge comes from the battery, which is Q total. So we need total charge. To get total charge, we need to calculate the total capacitance or equivalent capacitance. First of all, we calculate the total capacitance of C2 and C3. They are connected in series. So C2 and 3, because they are connected in series, we write 1 over 20 plus 1 over 30, all to the power -1. By using the calculator, this becomes 12 microfarad. Now, C total for the whole combination equals C1 plus C2 and 3 because they are connected in parallel. C1 it is 15 microfarad and C2 and 3 is 12 microfarad, so the total capacitance is 27 microfarad. And V total, it is the voltage from the battery. So V total equals 0.5 volt. Now we can get Q total. So in part B, Q total equals C total V total. C total equals 27 microfarad multiply V total 0.5 volt. So the answer 27 times 0.5, by using the calculator it becomes 13.5 microfarad and volt. So the answer in microcoulomb. So this is the total charge or the charge that passes through the point X. Now in part C, find the potential difference across the capacitor C2. So we need V2. To get V2, we need the charge that passes through this branch. First of all, what is the charge through C1? The charge through C1, which is Q1, it's given 7.5. So what about the charge through the series Q2, C2 and C3? So Q2 here in part C, Q2, it is the charge through the capacitor C2 equals Q total, this is Q total through the point X, minus Q1. So Q2 equals Q total minus Q1. Q total equals 13.5 microcoulomb minus Q1, it's from the given Q1, it's 7.5 microcoulomb. 7.5 microcoulomb equals 6 microcoulomb. This is Q2 and already we have C2. C2 it is given, which is 20 microfarad. From Q2 and C2 we can calculate V2. V2 equals Q2 over C2. Q2 equals 6 microcoulomb and C2 it's 20 microfarad. The same way we cancel micro with micro. Then it is 6 divided by 20, which is 0.3 coulomb per farad. It is volt. So V2 equals 0.3 volt. I hope you understand this lesson. Thank you.